This time on Jarris of All, I go from this to this. Last time on Jarris of All, I failed miserably at trying to weld all these pieces together for this sword. But after messing around with it for a really long time, I came up with a new technique, and I'm going to do it a different way than I was trying to last time. And that requires making sure everything stays in place, because warping is the enemy when it comes to curved pieces of metal that you're trying to weld together. I'm going to weld scrap pieces of the front blade edge to this 3/4 inch square tube, because this blade to scale is supposed to be 1.066 inches thick, 1.07 basically. And these plates of steel are 0.118, 3/4, and then the aluminum plates that go on the outside are 0.078. If you add it all together, you won't even believe this, 1.066. Look at that, 1.066. You can't even fake that kind of accuracy. Well, you can, but I'm not. These two pieces of aluminum are the side plates that go between the blade edges. So they look small and weird, but once the blades are on them, it'll look just right. But these are going to be the foundation of where all the blade edges go this time. Instead of trying to make the blades first and then fit them to this, I'm gonna build everything on this to start with. And in order to do that, I need to make sure that these stay straight, because this stuff bends very easily, which is why I'm about to weld pieces to this square tubing, because this doesn't bend easily. And this will be the backbone inside of that while I'm assembling all these pieces. I'm gonna weld these scraps to this tube, and that will give me my internal clearance for the side plates. The reason I held this down instead of clamping it is because this plate isn't perfectly flat and level, but it's close. But every time you heat metal up, it expands just like most things. Amateur hour. Hey, what's up? I'm filming.
Filming what?
The next video.
Why isn't it done yet? I've been doing money, and I expect to know.
All right, sounds good. See you, man. Metal expands with heat just like most things. Anytime you weld anything, you're creating a lot of localized heat on the metal, and it makes it expand in that location. If you don't have enough reinforcement around that location, then it can warp the piece that you're welding, which is what causes all of the problems in this. But this bar should have stayed straight because it has enough material around it to keep it straight, even though those areas that I welded are trying to expand. Ready, set, weld. With all of these perfectly gauged pieces, I can set this thing up. It's gonna be precarious at first. I can set this thing up with basically what amounts to a rigid spine through the center of it. It'll keep everything square as I tack it together. This is extremely necessary for this piece because aluminum goes crazy when it gets warmed up. It moves around a lot, which I found out. Oh, what is wrong with this thing? It's just like painting a car. 90% of this is setup. The whole principle of letting a weld cool while it's clamped in place so that it stays in that shape is what I have to do to this, and I have to be very careful to make sure everything stays exactly where it's supposed to be, because it wants to warp all over the place. Because I'm welding curves and angles onto basically a flat sheet, it's very easy for those curves and angles to contract and cause this thing to warp in complex ways all over the place. And then it makes it very difficult to correct that, especially because of those complex shapes. There's no way to clamp them to beat on it with a hammer to make it go back into shape the way you want it to be. So I'm gonna mitigate the stupid way that I was doing it the first time by clamping the ever-loving daylights out of it this time. 1.057 inches thick, but that's close enough for me. I'm sitting here talking about how I've got this whole process figured out, and then I put the clamps on the wrong direction because I need to do the steel section first, not the aluminum. Because the aluminum can't be in place because of the way that I'm gonna assemble this thing. Because yeah, welding aluminum to steel is possible. The only way that I can find that you can do it at home is with the silver solder. But the silver solder is brittle and it's not supposed to be done for something that you're gonna swing around on the end of a chain and smash into stuff. So fasteners, obviously, that's why there's drilled countersunk holes. We'll talk about that later. Right now, I need to get these switched around so that I can get the steel pieces fit to the top. And once they're fit, then I can work on getting those pieces tacked in place. This is a very tricky part.
That's tricky. Tricky.
Because this is a big, giant, inch-thick hollow sword. Well, I mean, it's not that huge, but trying to make a sword that would normally weigh 50 pounds, weigh like 5 pounds. So this process is tricky.
That's tricky. Tricky.
And these rails are contained inside of the aluminum side pieces, but they need to be welded to the steel plates for the blade edge. So they have to be installable and then removable and weldable and then reinstallable, but then they also have to hold their shape this way and this way. And you know, each little curve tries to make this thing flex all over the place. So this is tricky.
That's tricky. Tricky.
But I think this way will work out for getting these pieces put together the way they're supposed to be. I want to show you the sword that's already done, but I feel like I should wait and make it a surprise. If you're an Instagram follower, you've already seen it, but that's the benefit of following me on Instagram, so. Back to metal shaping. Time to bend these curves again. Last time I did this to match my piece of wood, which worked out okay, but there was so much reshaping that had to occur to make it actually fit so that there was less space and less welding and less grinding, that I'm just gonna do it this way to start with because it's more efficient to just make sure everything meets up. Just a touch. The amount of curve The amount of curve that's necessary in these pieces is actually less than you think it would be because it's such a shallow angle, which also makes it really difficult to get them accurate because you're trying to do just a slight curve to make all these edges line up over long distances, and they build on top of each other. So one little screw up here could make this edge off and then all the other ones are off. That also might be because of my accuracy when I cut them out, but whatever. And I realized that it doesn't have to be quite as accurate as I was before because I can fill with weld and grind back. You know the old saying, grinder and paint makes me the welder I ain't. So this is one of those good enough for government work type of situations. Mostly I'm just trying to make sure that the top edge of the longer width pieces is straight down the center line of my jig that I've got set up with the side plates because that is going to be the blade edge. This seam here doesn't matter quite as much as I thought because I came up with a way to deal with that later on in the process. So now it's just a matter of getting these two to line up well enough. Just the tiniest of curves. These pieces are difficult to make for different reasons. The long pieces are hard because the slightest bend far away can make a huge difference at the other end, but they're very easy to shape because they're long and you have leverage. Short pieces are difficult because you have to beat on them with a hammer and hope you get it right, but they're a lot more forgiving because there's less distance from the bends. Man, see, I just put the tiniest little kink in that and it was too much again. Tell you what does matter though, the gap between the side plates and the steel plates is not that big of a deal, but the distance apart that the bottom of the steel plates are does matter because that's going to cause issues in the overall shape when everything gets filled and ground back. Oh, I was about to tape this. I forgot. I need to grind the bevels into these while I'm putting them together so that everything lines up the way that it's supposed to. After this end bends up, it kicks that corner out towards the next piece. The next piece gets bent down that way, and then you have this huge gap between the two. I don't have to entirely close that up, but I need to take out that extra space that's created right there. So I need to grind these now. That way I can fit the next piece because everything builds on each other. It's way easier to take one end to the other. Doing this process, it's already difficult enough. If you tried to go from both ends, then you'd have to line all these pieces up based on more points of contact instead of just making sure this part is right on that seam and then worrying about this one next. Can't do things with gloves on. Now that I have this piece set, it's time to move a couple clamps around. One clamp, it's time to move the clamp and do the next piece in relation to this. I'm using electrical tape because I'm not tacking them right now and it's stretchy. so it holds it in place really well. This tape is strong and you can weld with this attached to the steel and it won't melt and form a big goo pile like the electrical tape will, but this is not stretchy and won't keep tension on it to hold it in place. So it's a little bit more difficult to use this to get things set up. I'll have a link in the description to my Amazon store where I'll have all the stuff that I'm using for this project. This process of bending these pieces takes far longer than I remembered, so I just went ahead and bent all of them. It takes hours. This is one of those situations where in a video, people try to make it seem like it's easy, but I want you to know that this process sucks. It takes absolutely forever. But they're all done, so now I can move on to tacking them in place. But there's a process to this because of the screw rail that has to go inside. So now I can tack the steel blade together, but then the screw rail has to get installed, so it all has to come apart. Because of the complex nature of all these curves, you'd think that this would hold together and it wouldn't warp that much because all of the curves would fight each other, but I think the big reason that this thing warps so much is because of the residual stresses from bending these pieces. And then when you apply heat, certain parts of the metal weaken and they're allowed to flex back. But with tacking in this many places and not introducing that much heat to the piece, it's staying where it's supposed to. So far, so good with my new technique for building this in a more efficient way. Oh, and I didn't put that fancy tape on because I knew the tacks would just melt a little bit of the electrical tape. And this is all gonna get ground down anyway, so it doesn't matter if it gets a little dirty. It's all off, and it is in perfect alignment. I can show you from every angle because it looks great no matter what. And this is ready to just be put right back on. There's just one problem with this. When I put the screw rail on, I can't weld down through the middle to attach the screw rail to this. And even with this off, if I tack the screw rail at the ends, just at the ends to hold it in place, there's nothing for me to weld the screw rail to because it sits just inside of that. And it's thick enough that I can't get down in there with the welder nozzle to be able to weld that. I need to install a couple little pieces on this first on the inside so that I can weld the screw rail to it after it's tacked in place. Gotta attach the screw rails to the plates. These are my screw rails. I made 2 of them, 1 for each side, and they need attached to the plate so that I can attach them to the blade, just like so. They were match drilled, and in order to do that, I had to drill them clamped together with 1 size drill bit to drill a hole through the aluminum for the screw to fit through it, and then a number 30 drill bit for the tap to go in because I had to tap them for 832 screws because this was the best size aluminum screw that I could find. And these are countersunk. So then after I did that, I had to countersink all the holes. So it was 24 holes, but it was 4 holes for each hole that I had to drill basically. 100 holes. No, 98, but no, 96, yeah. Can't do math. And I had to do it for the other one, so it was almost 200. I have to do this by hand because these screws are made out of aluminum and there's a very specific reason for that I'll get to later. But if I were to use one of these things, an impact driver, it would rip the screws in half because aluminum screws are not that strong. So by hand it is. Time consuming, but I won't break all my screws. Obviously these screws are too long and I knew they would be way too long, but to get this diameter, these 832, the next step up was even longer and I wanted a certain amount of thickness for a certain amount of strength, but yeah, I gotta cut them off. I got my thing clamped. This is all set up. I checked it thoroughly, and it's right, and I put this back on, and I don't know if I didn't check the alignment when I welded it or if it moved. I think it may have moved. This one pulled, so everything is perfectly lined up, but the tail goes over there by, I'd say 2 millimeters, but it's enough that I can't get this tacked together because it doesn't fit like it's supposed to. So I gotta cut it in half and bend it back and re-weld it. Aha! As soon as I cut that weld, it lined right back up on its own. There must have been tension on it from one of the other ones. But as soon as I got through that weld, it went, and now it's perfectly lined up. Good to go. All clamped up and lined up and ready to go. I'd say this is the moment of truth.
Moment of truth is here.
But with metal, there really isn't a whole lot of like moments of truth because almost no matter what you do, you can redo whatever you do wrong. But it will require a lot of work if I screw this part up. So let's hope it stays the way it's supposed to. I have thought about the orientation of this before I started welding to make sure I could hit both spots, but here we go. Oh. That end with the screw rail is now one piece. Whoa. What is it doing? Now I need to wait for those welds to cool before I remove the clamps, because now I need to flip the clamps to the other side, take the spine bar out, and just put the spacers in, and then clamp those in place so that I can put the aluminum on. There's no point in disassembling the whole thing to weld that stuff in place when it's already jigged together like it is right now, because now that those parts are tacked, the aluminum can get tacked on, because this is gonna become one part. Now we wait. It's all jigged up now. And the last time I did this, I was afraid because I'd only done it once before and I didn't really know what I was doing, but then I got a lot of practice. And now I do. And I have the settings right on the welder, and I'm not afraid to go ham on the pedal to give me a bunch of amps to get a tack weld on this and not melt through the pieces like I did last time. Pride before the fall. Let's hope I don't screw up this time after I said how good I am at it now. Oh, I need to turn the welder back on. Here we go. It's not a pretty tack, but it's a tack and it's in place. It's together. I don't care how big it is at this point, just as long as it's holding together. It's the whole point right now, is just to get this thing assembled. This aluminum moves around like absolutely crazy. I understand why people say aluminum is difficult to weld, because it is. It moves around all over the place. It doesn't do what you want it to do. It's nothing like welding steel. The process is a lot harder than most people make it look like when you watch welding videos on the internet. Come on. Oh, I didn't check it. I didn't realize it had lifted. This is the problem with trying to weld on camera. If you can see it, I can't see it. That looked like it was perfectly together. It's obviously not. Try this again. Proper tape. It's ugly, but it does not matter. I need these things to hold in place. That way I can take my time and do decent welds. This part is the worst part of this whole back section because these pieces are so small, there's no way that I can use even the welding tape to hold it in place while I try to tack it on. So I'm gonna have to try to fuse weld it because I can't use filler rod. And this is the real test of my aluminum TIG welding ability. Bingo. I can't believe I actually did that. Now I just need to get it lined up. Almost there. 3 more pieces after this one.
I hate these gloves so much. They're so friggin' tiny. You have feeling with your fingers, but they're so small you can't move your hands.
Tacks for days. I'm getting better. Last piece. Here we go. Okay, it's tacked. This process has been a long time coming. And once this one is tacked, the second sword is finally put together. Need one up here. Oh, no I don't. It's in place. This is finally assembled, but that doesn't mean it's done. I need to spend about the next 2 days welding all of this together. And the reason it's gonna take that long is because I need to do small areas of weld as I go along and let them cool so that the whole blade doesn't warp, which is what I did on the other one. I don't want to have to do that again because that took a lot to fix. I can't finish this one right now, but the other one is to the point that this will be at in a couple days where the whole thing is welded and then ground back. Ta-da! Now, the one issue between this sword and this one, I split these panels in half so that I could weld the inside of the aluminum seams and the outside and then grind them back. That way they'd be nice and strong. With this one, I can't do that because the aluminum panels that are the side plates are all in one piece. But I have aluminum brazing, which is nearly as strong as aluminum welding. And I'm going to braze the inside of this once I take all of the screws out and have the outside welded. But I'm also gonna use that to cover up the screws and the seams between the steel and the aluminum. It won't glue the two together, but it will hide the crack. These screw heads are countersunk, but they are dome topped, so they have to be ground back so that I can cover them with the brazing. Pro tip, don't use a steel grinding disc when you're grinding aluminum. You have to get an aluminum disc. It says specifically on it aluminum, and it's because it has a special adhesive that releases as it gets caked up. There are spots on this that are caked, but as I grind, they release and they fall off. If you use a steel grinding disc, it will cake up with the aluminum and it won't release. It'll become imbalanced and then it will probably make the disc explode and injure you severely. I've used this stuff before. It's called Illuma weld rods. You can get it at Harbor Freight. I use this to put together new tails for motorcycles when I used to customize those back in the day. And its melting point is its working temperature is 730 degrees Fahrenheit, which is awesome. And I don't know what's in it because aluminum's melting point is 1220 or 660 Celsius. So I needed to test this to make sure that it's actually gonna work for my purposes because I'm gonna weather this blade with aluminum black. So no matter what else is in it, it still turns black with the aluminum black. Now it's time to fill in all the stuff on the blade with this stuff. Aluminum is an incredible heat sink, so it might take some time to get this whole thing heated up, but once I get it up to temperature, you use this rod and you can push it into the surface. As long as the aluminum is clean, it'll bond with it. And I did some tests with it and it bonds very well and it is very strong. So here we go. The steel that I'm using is mild steel, so bringing it up to 730 degrees would take it beyond the temper point, but since it's mild, it doesn't matter, it's not hardened. I'm gonna heat this stuff up. You can tell when I'm getting close to the right temperature because the steel starts to change colors as I approach the working temperature of this rod. It's nearly there. There it goes. The oxide layer that develops on aluminum the instant that it's exposed to atmosphere can be abraded by this rod as you rub it into place. As I do this, I rub the rod and it bonds to the aluminum. Actual aluminum to aluminum bonding. It doesn't matter if I touch the steel with it. It'll just come right off when I grind it. But I need to make sure those gaps are filled. Now that I've got the gaps almost entirely filled, scratch that, entirely filled on the top side of the sword, I need to stop because the melting point of steel when you're welding it is really high. I can't remember what it is. Pretty sure it's over 3,000 degrees. No, maybe it's 2,600. It's far beyond the temperature that aluminum melts, and it's far beyond the 730 degrees that this melts. Can't use this on the bottom half until I put the handle on. But I wanted to do this first just to see how it would work out. I feel like when I grind it back, it's gonna look really good. And for what this thing's gonna do, it's gonna be more than enough to make this look like an actual Blade of Chaos from the God of War. I have the sword blade jigged up on a very thick, very flat piece of steel, and I'm going to tack the handle on. The handle happens to be a piece of steel tube that I got that is 1.05 inches thick, which is almost the 1.066 that the blade is. Anyway, I'm gonna put that on, but I'm just gonna tack it on for right now, because if I need to, I can reshape the guard in the future to move the handle around where it's mounted on the blade to help this thing have flight dynamics. You know, the rocket science thing that I talked about in the first build video. Time to tack this thing on because I really want to test it and see if it actually flies. This has also been very carefully lined up with the template so that it is mounted in the exact angle and location that it is for the game model. See if that works. Ready, set, weld. I gotta put a loop on the end so I can put this thing on. I found this in my friend's garage and I'm gonna use it as the swivel to connect a rope to so I can swing this around and see if it works. That janky little connection is gonna be far stronger than the rope that's about to get attached to it, so it should be fine. And now, with this thing being hot and PLA melting at a very low melting point, I might be able to melt these guards onto the blade that I printed out just as a test. I'm gonna provide all of the files for this sword to my Patreon patrons, but I can't provide this because I had to buy this file. But if you do want to subscribe to my Patreon, this is what you'll get access to. Exclusive content that's only available to my patrons on Patreon, as well as your name on my work table of Patreon names, which will be updated very soon. It takes a really long time to cut all his names out, as well as the satisfaction of knowing that you help to support the builds that I do on this channel. If you're interested in joining, the link is in the description below this video. Let's see if I can melt this on. Hopefully it's still hot enough. Yeah. Yes, it's squishing. There it is. All right, that side's good. I'm gonna cool it off as quick as I can. This stops melting and I can go test it. Good enough for our first trial. Let's go swing this thing around. Obviously, these things are far from done, but it's far enough along that I can give it a reasonable test to see if it's actually gonna work. Weeks of effort come down to this moment. Here we go. Blade first is the goal. Let's see if it works. Is it spinning with the rope? It's just spinning. It's spinning with the rope as the rope rotates. Ha ha! Look, it's not spinning blade first, but it is close. It's nearly there. The weight of the blade is carrying the edge towards the ground. The faster I go, the more it turns blade first. Okay, I'm very dizzy. I got it. I have to make some adjustments, but it is close to flying blade first. I think the difference is gonna be where the handle is mounted. If the handle mounted towards the front, all of the weight from this will be up here and it'll cause this from the drag, because this is static, to be behind and it should fly correctly. I knew this could potentially be a problem when I very first started making these. And I had an idea when I first came up with this to be able to make these fly blade first and make them look even more realistic to the game. So make sure you're tuned in, subscribed, with notifications turned on so that you can catch the next episode where I finish these and make them look absolutely game accurate, and the test video where I become Kratos and actually use the Blades of Chaos as they're meant to be used. Thanks for watching. I'll see you next time.